have looked at double replacement precipitation reactions, and I'm glad to see that I think about half you guys are doing pretty good with that. A third of you understand it pretty well. You're missing the little details. You're just not mentally with it yet. And then a third of you are totally lost. I get that's totally normal for me right now. Okay? But we need to go on, and I want to introduce you to the two other types of double replacement reactions. By far, double replacement precipitation, drip, is the most difficult one because you have to memorize a song. And if you do not memorize the song by tomorrow, then you will fail the first quiz, fail the second quiz, and fail the third quiz. You will fail all three quizzes.
But you can retake them, correct?
Eventually, yes. Well, I mean, not tomorrow. You can eventually, but things will get much more complicated. So how about if we just memorize the song, and that way we can succeed tomorrow. And if we do have to retake it, we have to retake it because of the little details that I expect you to know. Now, the details are as much an exercise in mental discipline as anything for me. I'm trying to teach you guys to be mentally tough. Even you football players, you understand the importance of attention to detail when you're studying film, right? Even for you quarterbacks, right? You go up there and you have to very quickly scan the field and see where the defense is. And in your mind, you're beginning to move them in where you're expecting them to go, right? That's tough. Okay, that comes with mental discipline. So if you don't like all the little aqueous and the little charges, tough. I'm trying to teach you to be mentally tougher than you are right now. And that comes with practice and pain. Okay? All right, let me introduce you to the two other types of double replacement reactions which are not nearly as tough as precipitation reactions. First one, DRAB. What does DRAB stands for? Double replacement acid-base reactions. What makes these things a whole lot easier is because they are all end up having the same answer. Why? What are double replacement reactions? Well, acid-base reactions. They involve an acid. So anything that begins with H is what we call an acid. Anything that ends in OH is what we call a base. Since this is a double replacement reaction, we're going to exchange partners. And the H from the acid will react with the OH from the base to produce water. These reactions, by definition, have to produce water. So instead of having to worry about what the the song says, you know what it has to produce. It has to produce water. Now, the reason why I write water that way is that you can clearly see the two parts of water. Now, the other thing that it will also produce is going to be what chemists call a salt. I know that you guys call salt sodium chloride, but chemists call a salt anything that is produced from an acid-base reaction. I am so congested. I can breathe again. Yay! Breathing is so unappreciated.
Hey, Mr. Moreno.
Yes.
Since oxygen makes a combustion reaction,
Yes.
where do you breathe? Are you burning yourself?
You know, that's really good because in a way, yes, When you're breathing in the oxygen that is needed for the combustion reaction to occur in your blood cells. The glucose is the hydrocarbon. The oxygen you're breathing in is the oxygen, and it produces carbon dioxide that is expelled along with water vapor. So yes, teeny tiny little explosions are going on inside your cells. The energy is captured and converted to what chemical? Who remembers from biology? No, the energy that is produced in the burning, the combustion of glucose goes to the formation of ATP, which is a molecule that stores energy. All right, here we go. Solutions of sodium hydroxide. Gang, I cannot stress enough that here in this first step, what we call the molecular equation, you must write correct chemical formulas. If you don't, then you start out wrong and you're going to continue wrong. Sodium hydroxide. Sodium is +1, hydroxide is -1. So, and I said solution, so that's AQ. I write the charges for your benefit because I know how to write these things. You need to, if you do write the charges, please scratch them away because the charges should balance themselves out. Hydrochloric acid. Okay, so it begins with H, and because it's hydro, that means that the H is bonded to an element. Which element? Chlorine. Solution means AQ. Okay, so I got a guy-girl situation. Guy, girl. So I need to trade partners, and I am not surprised that... What do I form? Which is a liquid. And the leftovers. Now, there's one sodium here. Does that mean there's going to be one sodium on the other side? I don't know. I don't take the one there. I just put the ion for me to see. I have one here. Does that mean I'm going to need one on the other side? Maybe. Maybe not. I don't know. Okay, that is a correct chemical formula. So in this case, yes, it worked out that way. Sodium, is it in the song? No. But it is an alkali.
Yes.
And alkali metal ions are really swell. They're always soluble. Okay, so all acid-base reactions will result in the same thing. Liquid and aqueous. It always follows the same pattern. Okay? Is this balanced?
Yep.
Okay, then anything that's aqueous needs to be broken down into its ion because that's less deceitful. It's more truth. And if it's an ion, it needs to have a charge. If it's liquid, leave it alone. Liquids, solids, and gases do not get broken down. If I've done my job right, there should be 2 ions on the left and 2 ions on the right that are exactly the same. Are there?
Yes.
If it doesn't work out that way for you, then guess what? You did something wrong. Something's wrong. You better go back and check. All right, final answer. And this should be the final answer for every one of these. It should be the final answer for every one of these.
Like exactly this.
Exactly that. You'll see what I mean. You'll see. Trust me, buddy.
So in that pattern of those exact colors.
It'll follow this pattern.
So it basically like checks itself.
Yes. Yes.
So what's our goal by doing this? If we know what the final solution is going to be, what is our goal by?
Okay, I have several goals. First of all, you understand that acid-base reactions always result in the formation of water. Okay, neutralization. Secondly, my other goal is really by taking you through logical steps, I'm improving your ability to think logically. So I have kind of like a thinking skills goal, and I have a chemistry goal. But you're right. Next year, if you go to AP Chemistry next year, he's going to give you a question like that. Bam, that's the answer. Has to be. Okay? He won't ask you to do all this stuff. I'm asking you to do this stuff because eventually he will require it, because that's part of the multiple choice section, and because it helps you to teach to think more logically and with attention to detail. Maxine, ask y'all's parents if their job is dependent on their attention to details. All right, this is a reaction normally it's hard to see because everything here is invisible basically. So they're going to add an acid-base indicator. Acid-base indicators are quirky little chemicals that change color in different pHs. So if it starts out very acidic, it'll be a certain color, and if it becomes a base, it changes color. The other thing I want you to notice is that you know how Northerners make fun of Southerners for some of our dialects, and I have to admit that some of the Southern dialects are kind of ugly, but I think a lot of them are beautiful. And I like some of the Northern dialects. Whoever is talking here, he has an ugly dialect. I think it's from Boston. Wow, listen.
We'll react hydrochloric acid with sodium hydroxide. The two solutions are colorless, so it's difficult to see what is happening. The acid-base indicator is bromethymol blue, which is yellow in acid and blue in base. As we add the sodium hydroxide solution, the indicator changes from yellow to blue as the solution changes from acidic to basic.
Okay, it's beginning to neutralize. Still acidic. Still too many H's.
Sodium
Now it's base.
chloride and water are produced in the reaction.
So the water was produced. All right, let's do another one. Yes.
Okay, you know how like at restaurants the inspector they check the water to make sure you have products and all that?
Yeah.
And they stick these little papers in it. It has to come out certain colors.
Acid-base indicators, yes. That's good. That's a good job. And pools also. Those of you who have pools. All right. Sulfuric acid. You better write a correct chemical formula or else we start out this wrong. No hydro, so it's not an acid plus an element. This must mean that this is ic sulfate.
Can I tell you that answer?
No. I could tell you the answer.
But I can tell you the answer.
That's true. I'm glad that you've picked up on that. Okay. Is that right? HSO4? No. What is the charge on hydrogen? What's the charge on sulfate?
Mine's two.
So, something that simple will get you started on the wrong foot. And it all goes downhill after that. Potassium is plus, hydroxide is minus. Solutions means it's aqueous. Okay. So something that begins with a hydrogen, something that ends with a hydroxide, what must it form?
Water and alcohol.
Water. And what's left over?
Potassium.
Okay, I have one potassium here. Will I necessarily have one potassium on the other side? I don't know. I better check. Potassium is +1. Sulfate, that 4, does it stay with the SO or does it go over to the and it stays. SO4 -2. So it's K2SO4. Be careful. It didn't have a 2 here, but it has to have a 2 here. Yes, Gup.
What happens to the other H then?
Chill. You're right. Is everything written correctly? What's wrong? Which one did I mess up?
HOH and the KOH.
What?
KOH and HOH.
What's wrong with those?
Okay, so there's.
Okay, I'm not asking you whether it's balanced. I'm asking you whether each chemical formula is correct.
The chemical form.
Are the formulas correct?
Yes.
Okay, now we need to balance it. 2 H's, Gup. How many H's right there? No. Remember that water is made up of 2.
But this is what I said though.
I know, but I wasn't ready for it then. How many SO4s? How many Ks? How many OHs? Morgan, I'm trying to get you guys to stop. Don't balance ahead of time because you could actually end up screwing yourself over. Stop. Write correct chemical formulas. Then balance. All right. This little 2, does it stay little or does it become a big 2? It has to become a big 2 because that 2 is just a temporary 2. It's to balance with the sulfate. The little 4 stays little. Big ones stay big. And remember to distribute through the big ones. All right, liquids stay together. Don't separate liquids. Little 2, does it become big or little? Little 4, does it become big or little? Is it always with the SO? It stays little because it's always a part of the SO. If we've done our job right, there should be 2 ions that are exactly the same. Final answer?
Can we just like take all the 2's out?
Hold on. Well, Mr. Marino, I thought you said that these things always had the same answer. H plus OH negative yields HOH. This says 2H plus and 2 OH negative yields 2HOH. It's because this is really not the final answer. Your final balanced equation should be in lowest whole number ratio. So, Allison, yes, take out the 2's. You're doing very well. Any questions on this one? Behold, folks, it is November 13th. I have never seen it snow on November 13th. Oh my gosh, we're going to get a snow day.
Oh my god. I told you, Phoebe, I told you. He told us.
Maybe they'll let us out early.
I prophesied for this happening.
Guys, come back to me. Come back to me. All right, let's try this one because we've got one more to go. Water solutions of ammonium chloride.
Does that still mean aqueous?
Yes, water solutions still means aqueous. Ammonium is NH4+, chloride is Cl minus, so that is correct.
Mr. Moreau,
Yes,
if it says water solution, you have
it means aqueous.
but you have to like put water in.
No, it just means aqueous. Yes. Chill. Hold on to your question. Okay, sodium. Hydroxide. And it's a water solution, so that means aqueous. Let's switch partners. Ammonium goes with? There's no guy.
Is it in the song?
No, there's no guy. Ammonium has to go with the other girl.
So, what? That's confusing.
Why? This is still double replacement.
I mean, yeah, but where'd the water go?
What water? There is no water. This is not an acid-base reaction, is it?
No, okay.
Ah.
Okay, you can stop tricking me like this.
Guys, in order for it to be an acid-base reaction, something has to start with H and something has to end with OH. Okay, does the song say something about ammonium?
No.
Yes.
Dang it.
Yeah, it didn't.
I never said that. Ammonium.
Many ions will precipitate, including phosphates, sulfides, and
Nope.
carbonates, and except
Look at-
when paired with ammonium, an alkali metal.
Okay, but look on the, I think the second stanza. All ammonium ions are soluble as can be.
Oh, okay.
Sodium, is sodium in the
Where's the stanza?
No.
sodium? Is sodium in the song? No, it's not.
No.
But it's an alkali metal ion.
So that there's all
Everything is aqueous. So what do we write down?
reaction.
Is that correct?
Yes.
No.
Oh.
Some compounds actually will not dissolve. Actually, they do not exist. They will further break down into other things. Ammonium hydroxide is one of two. So there are going to be two that you're going to have to recognize that can do this. Ammonium hydroxide will break down into a gas and water. Ammonium hydroxide breaks down into gas and water. Let me introduce you to double replacement gas producing reaction. I know. Ammonium hydroxide is something that some of you, well, probably most of you are familiar with. Who's got a cat? Cat? Do you clean the kitty litter? Okay, have you cleaned the kitty litter? Is there a rather pungent odor coming from the kitty litter? Is there sometimes? That's ammonia. Have you ever cleaned a window with Windex? And there's a pungent odor coming from it.
It smells so good.
That's ammonia. If you like it, then you're weird. Have you ever... Guys, I don't have the voice for it today. Have you ever been knocked out and somebody put smelling salts, or have you been around somebody that was knocked out and they used smelling salts? That odor, amazingly bad. That's ammonia. Ammonia is a more stable form of ammonium hydroxide. So at our pressure, ammonium hydroxide breaks apart into ammonia and water. Let me introduce you to something else that will do that. It is carbonic acid. Carbonic acid. Where have you seen the word carbonic acid? This is something you drink a lot of.
Carbonated.
Carbonated beverages. What they do, carbonic acid does not exist at our pressure. It always breaks down into carbon dioxide and water. So in order to keep it as carbonic acid, they pump soft drinks full of extra air, actually 3 times more air than normal, in order to keep it in this form. As soon as you open the cap or do the tab and open it up, then the air escapes and the carbonic acid begins to produce carbon dioxide. So these are two very important gas-producing reactions. I will allow you 1 minute to put it in your periodic table. Go. And I'll get your question afterwards. 59. I don't know. Find space. 59. 56. 55. 54. 53. 52. 51. 50. 49. 48. 47. 46. 45. 44. 43. 42, 41, 40, 39, 38, 37, 36, 35, 34, 33, 32, 31, 30, 29, 28, 27, 26, 25, 20, 19, 18, 17, 16, 15, 12, 9, 8, 6, 5, 3, 2, 1, and... Okay, so let's go back to this one. It produced ammonium hydroxide. Does ammonium hydroxide exist? According to your periodic table, we have to replace ammonium hydroxide with...
NH3G plus HOHL. I got this.
Now can we continue? Yes. Anything that's aqueous gets broken down. Anything that's G or L stays the same. Go. Does the little 4 go down or does it become a big 4? No. It is an ionic compound, so it comes down. I don't think we balanced this, but I think it's already balanced.
Mr. Moreno, why do you say G?
I'm just trying to be consistent, sir. I know how important it is for you teenagers, for adults in your life to be consistent. Since it's not jazz, it's gas, I decided that it should be called G.
Oh, we did it. No, it's gas.
That's the sound of it.
Oh.
Duh.
When you pronounce it G, it reminds me of the dance, jazz, or the music, jazz. It's not jazz, it's gas.
But jazz is spelled with a J.
That's right, so maybe we should be consistent and call it a G.
I'm really confused.
Just leave it be.
If I've done this right, what should I expect?
2 things on each side. Thanks.
Shouldn't it be gas?
I'm having one of those days.
No. Because gallium, gas, not.
There's germanium.
But, I mean, like,
I don't know how to do this now. No, it still comes out with the same thing because it's the original thing. Yes.
What else?
I don't know. Does it have to be like the every answer, the OH negative, H?
No, this is not an acid. This is called a double replacement gas producing. So if you produce ammonium hydroxide or carbonic acid, it's a Durgip.
So like
Dr. GP. General practitioner.
Yeah. Dr. JT.
All right, gang, let's do one more. There are only two types of gas producing. I just showed you one of them. Let's do the other type. Ready?
Carbonic. Ooh. No.
Hydrochloric acid is HCl. Sodium carbonate is Na plus and CO3 negative 2. So that's Na2CO3. And it said solution. Let me get rid of my charges. All right. Guy, girl, girl. So the H goes.
Oh gosh, you're going way too fast.
Yeah, should it, if you're trying to be consistent, shouldn't it be E?
It would be H2.
Just saying.
Ryan, drop it now. It's no longer funny. Okay. I was accused of going too fast. Are we at a point now where we understand everything that's happened?
Yes.
Okay, so the H needs to go with the CO3. Now, it's very important that you write a correct chemical formula. H is plus, CO3 is minus 2.
So H2CO3.
And all acids are, and now the sodium goes over with the chloride. Should we bring the little 2 over too, or just ignore it? This little 2, ignore it for now. Sodium is plus, Cl is minus, and all alkali metal ions are aqueous. Okay, wait a second. Aqueous plus aqueous forms aqueous and aqueous. No reaction. No reaction. Wait. Before you say no reaction, you better check to make sure that you did not produce carbonic acid or ammonium hydroxide. Because if you did, you are not done yet. So what does carbonic acid become?
CO2, do we have enough H's for that?
Nope, now we need to balance. 1 H, 2 H's. 2 Cl's, 2 Cl's. 2 NA's, 2 NA's. 1 C, 1 C, 3 O's. Yep, we're good now. Anything that's aqueous, break it down. Remember to distribute the 2 across. This little 2, does it become a big one or does it stay little?
Becomes a big one.
This little 3, does it stay little or does it become a big one?
Stays little.
And how do you know the difference?
Because it's part of the compound.
If it's part of a polyatomic ion, it stays little. Any liquids stay together. Any gas stays together. And if we've done our jobs right, what? 2 ions should be the same, exactly the same on both sides.
We're not done yet, are we?
We are now. I'd like to show you calcium, I'd like to show you ammonium hydroxide being produced and then ammonia being produced. Listen to this guy talk. It's funny.
Boston?
I think so. Listen.
In the double displacement reaction of an ammonium compound with a hydroxide, we will place a small amount of solid ammonium chloride in the test tube. We will add some 6 molar sodium hydroxide solution. The test tube is warmed. The ammonium ion will react with the hydroxide ion to produce ammonia gas and water. The ammonia gas escapes from the solution. We can test for the presence of the ammonia
See the
gas
gases
by
coming
putting
out?
in a piece of wet red litmus
That's
paper.
ammonia.
The ammonia gas dissolves in the water, making a basic solution, which turns the red litmus paper blue.
Hey, I think it's such a neat thing about America that we have all these dialects.
Iron.
Ions. Ions. All right.